beam balance. Number 2, what does the letter DL stand for? Deciliter. What's the SI unit for mass? Kilogram. All right, so number 4, we're going to convert 125 grams to kilograms. So you have 125 grams, kilograms. Which one's bigger? How many spaces between killi and gram? So 3 zeros. So when I divide, I get 0.125 kilograms. Questions about that? All right, number 5, you have 35.6 decimeters. We're going to millimeters. That's what I just made. All right, who's bigger, a millimeter or a decimeter? So we're going to put a 1 beside the decimeter. How many spaces between deci and milli? 2 zeros and a 1. We're going to multiply, so I'm going to have 3560 millimeters. Questions about those? All right, the last one. What can you tell me about a milliliter, and a centimeter cube? They're the same. So the answer is 28.7 centimeters cubed. There's no need to draw a chart because they are one and the same. Questions about anything in the opening? Everybody go to those? All right. So you'll draw a line under it and prepare for opening number 2 for tomorrow. Put it in the safe spot. Don't lose it. Again, I collect them in batches of 10. Okay? On test days, we typically don't do an opening. So what? It's homework, right? And we go over them every day. So every time we collect these, you should get what kind of grade? 100. Now, if you're absent, you have to do this. Yes, you do. So back here, very back in the room by the door, in the notebook, there's opening. So if you come back the next day, opening in the notebook. So look, date, and fine. Alright, your job to make up what you need. Now, you're one of those who watches or check that YouTube, and I'm really on top of things. I've already started video, and the opening is there. Okay? So, the video for today is already live, so if you had checked, the video is already there, you could have got it. Questions? Alright, let's talk homework real quick. So, if we look at your homework questions, talk answers on the homework. Question number 1. Should have an answer of 0.0156. Now, of course, the leading zero you don't have to have. I'm just trying to emphasize the decimal. So decimal 0.156 meters. Question 2, 1.25 hectometers. Number 3, 0.35 decameters. Number 4, 650 hectometers. Number 5, 16840 millimeters. Number 6, decimal, 3 zeros, 156 kilometers. Number 7, 15.6 centimeters cubed. And number 8, 956,000 centimeters cubed. Oh, yep, I flipped them when I wrote the answer. I inverted it. Yep, 965. You're right. Question. Any of those you want me to do? Sure. All right. Now, this is part of what you had to watch last night. So yesterday, the piece that y'all missed is 1 centimeter cubed is equal to 1 milliliter. Okay, those two units are one and the same. They're the exact same thing. It's often easier for me to write milliliters when I do a test because that requires me to use a superscript that I have to highlight it and then change it with a superscript. Pain in the rear. Okay, but they're the same exact units. There's no difference between them. Okay, now if I look at the question they asked me, it said to take 956 liters, right, and change it into centimeters cubed. So I'm still doing it. Alright? So if I look at what they gave me, I'm going from something that is not cubed into something that is cubed. Alright? So anytime that happens, I have to use this right here. So the easiest way to do that is to remember that this is equal to what? This is the same thing as a what? The same thing as a milliliter. So all you're doing is changing liters to milliliters. Okay? Because if this is a milliliter, now you're just changing 965 liters into milliliters. Now, that looks like what we did when? Yesterday. It's identical to what we did yesterday. As soon as you change that centimeters cubed into a milliliter, it's yesterday's conversion. Because which of these two would be bigger, a liter or a milliliter? Yep, and then you can say King Henry died by drinking chocolate milk. If liters on the baseline, how many spaces between a liter and milli? So 3 zeros. And then all you have left to do is to do what? Multiply. The connection you have to make is milliliters and centimeters cubed are the same. Say what? I don't like that number 6. All right. You can. I would take either one. Okay. Either one are fine because they're one and the same. Question. Anybody question on anything else 1 through 8? So we were good on 1 through 7. It was just 8 to bottom. Okay. So let's talk about something else we didn't get to yesterday. Suppose that I gave you 400 and let's just say 45.2 centimeters cubed, and I wanted to change it to meters cubed. Now, what makes this question different from the one we just worked? What? Well, you may have said it right. I can't hear you. All I get is you gnawing on that straw. They're both cubed. Okay? Here, both units are cubed. Okay, this is the first one we've done where both units are cubed. The one you did in question 8 only had how many units cubed? 1. This one has both units cubed. And that's going to make a difference in how we solve the question with the chart. So all of the steps are the same except for one. So setting it up, 45.2 centimeters cubed, centimeters cubed, meters cubed. Who's bigger, a meter or a centimeter? Okay, so put your 1. King Henry died by drinking chocolate milk. How many spaces between your meter and your centimeter? All right, everybody does realize that meter is here, and that's why people said 2 spaces, right? Okay, so a lot of times people just glance up here. What do you think the mistake is that they make? That's right. They go to millimeter to centimeter real quick, and they're like, oh, it's only one space. And they want to do that. But remember, meter is a baseline unit, so it's two spaces. So don't be thrown off by that. Now, here's the new step, the only new piece you have. When both units are cubed, you cube the numbers. Okay? Cube the numbers when both units are cubed. Okay? You're going to cube the numbers when both units are cubed. You don't do this when it's only one. Okay? It's got to be both. Now, does everybody know how to punch that in your calculator? So, if we take our calculator, remember, cubing something is that up caret key, right? So, 45.2 divide 100 raised to the third. We're going to get an exponent. So, when we write this down, on the calculator, it says 4.52e negative 5. Now, we have to translate that answer into scientific notation. That's not the answer. That's not what we write the answer. Okay? We have to translate that into 4.52 times 10. This e that it's given us is saying to you, the exponent is a what? The exponent is a negative 5. So you have to write times 10, and then the exponent is a negative 5. Now, what unit goes on our answer? Back up here, what do we wind up with? So we write meters cubed at the end of it to put a unit on the answer. Question. That's the answer. Done? Yes. Do y'all remember scientific notation from math class? We're getting ready to talk about it. I just wanted to translate what you got on your calculator. Y'all look at me like she's crazy. Y'all never saw scientific notation in math class? Some people are nodding, yeah. Okay. All right, let's talk scientific notation, then we'll do something. All right, first of all, scientific notation, we're going to use it here quite a bit this semester, is for very large or very small numbers. Okay? That's what it's for very small and for very large numbers. For example, when I call out a number a while ago, and I kept saying 1450000. In science class, we generally don't refer to numbers that way, or we don't say 1,450,000. We generally put those numbers in scientific notation. So, at some point in your math career, some teacher, and you probably remember doing this, asked you where the decimal was in this number, and you said it was where? At the end, right? Now, scientific notation is defined as a number between 1 and 9. So what number would be between 1 and 9? The 1, right? So this decimal has to go all the way up here between the 1 and the 4. So we have to go all the way up there. So we're going to have 1.45. times 10. Now, how many places did that decimal actually move? 1, 2, 3, 4, 5, 6. So, that 6 represents the number of places the decimal moves. Now, if the decimal moves left, it's a positive exponent. If the decimal moves to the right, it's a negative exponent. Well, since this one moved to the left, we make it a plus 6. Ever remember seeing that before? Yes? Jaden, Baden are nodding yes. So Andy's nodding yes. Somewhere in your math background, y'all have seen this before. Okay? So if you have a number like 0.00521, 421, all right, where's the decimal? Well, you can see the decimal this time, right? What number would give us a number between 1 and 9? Okay, we need to be behind the 4, right? So 1, 2, this time we're going there. So 4.21 times 10, and how many places did it move this time? And this time it moved what direction? So we're going to make it what? Now, before some of you are freaking out over there going, oh my God, I don't understand what the woman's doing, calculate this is what. Okay? Don't have to do it yourself. Calculator will do it. You get a calculator every time you take a test or quiz. Now, we also need to be able to put it in the calculator when we multiply and divide. So, does everybody have what they need right there? Anybody still writing out there? No? Yes? Oh, here you go. All right, so let's say that you have a number like 1.47 times 10 to the 8 times 4.82 times 10 to the 7. Then you have to calculate this and write the answer down. Now, you need to be able to put this number in your calculator, correct? And get the answer back out of the calculator. We want to let the calculator do the work. Some of you probably learned how to calculate this longhand, maybe in Algebra or Math 1. You're still going to need to do that in chemistry class. It's not part of our curriculum. So, the biggest thing that I will be ranting and raving about with several of you, and I will still be yelling at you about this in June because some of you will not believe me today, March, or in June, is that you do not hit the times or the 10. All right? This is a special key on your calculator. It is E. Okay? Now, most of you have probably the ones that aren't real old. So you're going to have to hit the second function and get the EE, which is above the comma, which is over there above the second. Some of you might have the older calculators, which you are going to have to get plain old EE. But most of you probably have the newer ones, which means you're going to have to get the second function EE. So 1.47, and when you hit second and EE, what pops up on your calculator? And E. Why are you supposed to use that? It's saying to you, what is the exponent? That times 10 is programmed in the calculator because this is assigned to the calculator. It's just saying, hey, what's the exponent? So you say to it what? You put in that. What's frequency do? Now you hit one. And then you say 4.82. And then you have a times 10 again. So you do what for this times 10? You say second and EE. And then it's asking for the exponent, and you say 7, and then you hit equal. You ever hit times and 10? No. Okay? If you hit times or 10, it shifts the decimal place on you and you get the wrong answer. Okay? So when I do the multiple choice test and I need wrong answers, what do I do to get the wrong answer? I hit time. I hit time stop. Now I'm gonna write the wrong answer. So when you take the test next week, you'll be surprised how many of your wrong answers are there. And then you're gonna get the test turned in, you be like, really good, really great. I feel positive about that. Then you're gonna get it back and something else. Well, I got all of that. Yes, you did. Because I calculated them the way you did in the class to get the wrong answer. Okay? So don't let me mislead you and follow that rabbit hole right on down the path to the beat on the test. So, don't hit times 10. What'd you get? Sounds about right. All right, I'm going to round it up 7.08. We good with that? Everybody got that? Anybody not get that? Don't do your calculator. Anybody else? Not yet. All right, continue. No need to print it. Keep it right. Find the challenge, not that. Okay? Everybody got it? All right. All right. Calculate that one. What'd you get? Hmm? And we're going to talk about how to round Monday and Tuesday. Most likely Tuesday. All right. Question. All right. All right. You get an answer? Is it scientific notation? I want a scientific notation. Now, I don't want you to have to move that. I want you to make calculator do the work. How are we going to make calculator do the work? What do you remember from math class? What? Okay, that's what I'm doing. Got it. Come on. Who's last time you had that? Okay, that's easy. All right. How do we make a calculator do what? You could, but you might make a mistake. How do we calculate do work? Now, I'm all about making things easy. Work is smart, not hard. How do we do it, Amy? What you do on the calculator? I don't even hear it. You did all that? You use the mode key by any chance? Okay. You need to. That's a lot of work you did. How about y'all go to mode? What's the mode key? Tell me if you see anything that looks like it might be useful. You push the mode key, then use your arrow and go over to psi, and then hit enter. Anything happen? You got to clear it off the calculator. All right, and then hit enter again. Does anything happen? You should. Okay, you messed with it. Just recalculate again. Now, did you get scientific notation mean? Yeah. Now, if you don't want scientific notation to stay, okay, because you get your 2.41 times 10 to the third, and let's say you're working a different question and you need it back in the other notation. Are you just checking for stuff? Okay. Okay. So if you need it back in the other notation, what do? Go back to mode and then do what? Back to normal. And you can change it back to whatever you want. You can make the calculator do the work. You don't have to work hard. Work smart. Just toggle between normal and psi. Normal and psi. And you can change it all day long. Now, whatever Andy did works too, but you're working way too hard. Okay? Question. So now let's go back and convert using those cubes and not have to write down 800 zeros or be able to write our answer in scientific notation, know what we're doing. So let's say that I ask you to change 42.8. That's terrible. Let's do decimeters cubed to, I don't know, millimeters cubed. All right, what would I do? Okay. Next. Done. Next. Next. Okay. Y. Good. And then? I don't know, is it? How do you decide? King Henry died by drinking chocolate milk. So how many zeros do I have? 2 zeros. And then a 1. And then how do I decide what I do next? That's right, because both of these are cubes. I got a cube here and here. So when I put it in my calculator, 42.8 times 100 raised to the third, I get 4.28 E7. So how am I going to write that answer? Exactly. Question. Everybody with me? What's wrong? Did you say divide by 100 or multiply by 100? All right, where's the 100 at in the chart? Is it on the top or the bottom? That's why we multiply. If it was on the bottom, we would have divided. All right, does that make sense? Everybody with me? All right, let's practice a little bit. I'm going to tell you which ones I want you to do. I'm not doing this whole All right, so if you look at this one, I want to do, let's see, except this thing. Let's do the odd, except this thing. Now, before all of you go and do number one the easy way in your head, the reason I like the factor label method, all right, when you look at something like number one, all right, what did I give you number one? How many? In number one, what did I give you? $25. Okay. So $25 is your given data, right? So what goes on the bottom? What am I asking you to find? Who's bigger? So get the one. How many dimes are a dollar? So how do you solve it? Factor label method works for everything. It doesn't have to be for math. Okay? You can do that in your head, but my point is this method works for everything. Now, the two things I want you to do in these odd questions. I want you to write your answer in both sentences. So 250 dimes, and I want you to write it in scientific notation. So 2.50 times 10 to the second dime. Because on the test next week, you are not going to know whether I'm going to write all the answers in 6 decimals, which is the top one, or whether I'm going to write it in scientific notation, the bottom. So you need to be able to go between the two answers. The only thing I will tell you is all 4 answer choices are either all successful and they're all scientific notation. The majority of our tests are not multiple choice. There are a couple that are multiple choice. The first one is one that happens to be multiple. Right? Again, I'm doing the off. You want the whole time? This is the wrong. That's the left. Back side of the door, the one that's back on. That's right. Nope. Love it. I only have the door closed because I get tired of listening to the drum and pull it. I'm fishing. The bathroom is not that way. The same place the bathroom is always been. I just need you to take the bath. And sophomore grade. All right, let's go. Breath. It's not. All right, who else has a question? I'm not putting it in the group. What? Uh-huh. Amy? Yes, that's one thing. And you do more things, but I'm talking about that. All right, how about that? Anybody got a question for me now? How are we coming? Who's done? I got about five. Uh, Live off. Live off. All right, talk about what you got. You just got questions. Ow. All right, so question one. I already put that answer on the board. So everybody should be good with that one. All right, number three, 413 centigrams, 4.13 times 10 to the second centigram. Five, 728 weeks, 7.28 times 10 to the second weeks. Number seven, decimal 0.000472 kilograms, and 4.72 times 10 to the negative fourth kilograms. Nine, 700,000 millimeters, and 7 times 10 to the fifth millimeters. 11, 2.57 centimeters. That one cannot be changed because the decimal is the only place it can be is after the 2. Number 13, decimal 0.0587 decimeters cubed, and 5.87 times 10 to the negative third decimeters cubed. I told you to skip 15. Number 17, 4.17 times 10 to the sixth centimeters cubed, and 417 with 4 zeros behind it. 417,0,0,0 centimeters cubed. And the last one, decimal 0.371 and 3.71 times 10 to the negative third liter. Which one would you like me to do or talk about? 17. All right. The number 17, you have 37.1 centimeters cubed, and you need to change it to liters. All right, and this is the one we talked about in the homework. So you're going from something that is cubed to not cubed. So this is the one. So this is the one that you want to recognize. Centimeters cubed equals milliliters. You want to use this relationship to solve. Okay? So, what should we do? How do you think we would use that and incorporate that into solving that question? Okay. So we are going to use a table, but what connection do you think I want you to make before we even use a table? The milliliters is the same as the what? Yes. So I want you to realize that 37.1 centimeters cubed is the same as what? Milliliters. So I want you to realize that and then change it to liters. Once you've made that connection, then I want you to set up a table. Okay? And then go 37.1 milliliters to liters. Who's bigger? So 1, how many spaces between the baseline and milli? 3 spaces. And then when you divide, you get 0.0371 liters. And then you're going to have 3.71 times 10 to the negative second. Like that. Okay. Does that make sense? All right. Who else? Anything else out of the practice we just did? 13. All right. So 13 has 5.87 centimeters cubed. You're going to decimeters cubed. All right. So what can you tell me about this one that makes it different from the last one? They're both cubed. All right. So we're going to put 5.87 centimeters cubed. Centimeters cubed, decimeters cubed. Who's bigger? Put a 1 there. How many places between deci and centi? So put a 0 and a 1. All right. Because they're both cubed, what do I have to do different here? Cube them. All right. So this time, when I solve, I'm going to have, I'm doing it right in my head. I do that right in my head. Okay. So I'm going to have 5.87 times 10 to the negative third decimeters cubed. Okay? How do we feel? Okay about that? What else? On our homework. Or not homework. Practice. Everything else out there we felt good about? So any of these that are on there, we feel good about those on the quiz Monday. I'm not going to be suicidal when I grade these Monday afternoon or evening. I'm going to feel confident when I grade them. Be pleased. Yes. Okay. All right. Let's talk density. Again, density is a concept that you should have learned in middle school. Should have. All right. We're going to assume that Mario over there. Okay. That it's not like math last semester when you don't remember nothing. All right, because that was last semester, she don't remember nothing. So I'm sure that middle school is lost on it. All right. Somebody tell me something you remember from middle school about density. Don't know what you're doing. Not quite. Not quite. Tell me something else. Not feeling that. Something you know about dentistry. I like that a little better. All right, let's say time. All right, okay. What else do you know? Can you tell me anything about the formula? What variables are in it? The taste, the flow? What thing? Okay. That's something. I believe that. That's correct. What do you say? Correct. Okay. So, density is defined as mass per unit of volume. It is V equals M over V. Okay? That's the basics everybody should remember. Okay? Everybody in the room should have that. Now, from there, you should also remember what Jason and a couple other people threw in for good measure. If you have some kind of container, let's just say some type of beaker, you throw in some kind of object, all right? If it is more dense, it will sink, okay? If it is less dense, it will float, okay? Anything that is more dense will sink. Anything that is less dense, it will float. So, at some point in driver's ed, you probably talked about when it rains, when was the most hazardous time to drive when it rains? When it first starts to rain, because what happens when it first starts to rain? That's right, the oil and stuff floats up because the oil is less dense than the water, and so it's coating the surface of the road and it makes the road more slippery. You all know if you buy an oil and vinegar salad dressing, what happens to the oil? It floats. You have to shake it up so that it mixes with the water again because that oil is less dense. It's going to float. Okay? That is about density. Now, our job is to review how to calculate density. Now, before we calculate with density, I need to do chart. Now, when I give you this chart, put your name on it. These are the reference tables that you will get on exam day, minus the periodic table, because that's going to be 2 pages on exam day, and I've turned it to 1 page, so you're not looking at a half page this time. And I use that when we start that another week. Now, you can use this on every test and every quiz, providing you don't add anything to it that I don't tell you right, other than your name. You will get an identical copy of this on exam day. All right, so, everybody got it? Got it there? Hang on. You leave it in here and you get it back to you. Now, let's see if I can open up the file today and the board not go ballistic like it did yesterday Thursday. All right. Some of you are going to have fabulous math skills, and I'm not going to use some of them. Some of you have weaker math skills. Okay? I don't know who fits in what category. So if I'm insulting some of you, I apologize now. Okay? But I have found in my vast years of experience, I am better served to insult a few than to just jump over it and assume that everyone can do this and then be suicidal after I break the first two. Okay? So rather than just assuming that everyone can, if you feel comfortable and don't need to write any of it down, just don't write any of it down. Okay? We'll walk through a couple, make sure everybody's happy, then we'll just rush on. Okay? So if you were to have a question such as either of these things that are on the board, all right? These are pretty straightforward density questions. Plug and chug would be the way I typically refer to those. So in question one, if I said, what is the density? The only reason that I typically work with questions like the top one is largely to talk about the units that would go on the end. So, what's the density of an object with a mass of 12.5 grams and a volume of 3.89 milliliters? Now, that is as easy a question as you're going to find because all of the information is given to you in the question, and all you have to do is literally plug and chug. So, we're finding density. So that would be the formula we would want, correct? Which of those three variables am I solving for based on what question is asking you for? So we're looking for D. That means M and B are provided in the question. Now, because this has a gram on it, it has to be a mass. Now, do they have to say mass of in the question? No, because it says grams right there. It has to be mass, even if it doesn't say mass of in the question. Because it's grams, it's a mass every single time. So it has to go in for E. Now, 3.89 milliliters. A milliliter, we have learned, is a volume. So it has to be V, even if it doesn't say volume of. Now, the reason I pointed this question out, like I said a second ago, is to talk about the unit. When you divide those two units, do either of them have anything in common? Anything the same about those units? Anything the same? No. So when we divide this number and get whatever it is we get, 3.21, when we write the unit down, we have to keep grams over milliliters because neither of those units will cancel each other out. Neither of them are the same, and so you have to write both units. Now, to illustrate how that is different, I put this question here. Illustrate the difference. I'm going too fast for those of you who are writing. Okay. So in the second one, I asked to find volume of an object with a density of 5.64 and a mass of 89.5. So this time, I'm still using the same formula. But this time, I'm solving for which of the three variables? Solving for volume. So my density is what this time? And my mass is 10. Again, those of you who have stellar math skills, solve it any way you wish. Okay? I only solve it one way in class. All right? Baden, who's had physical science with me, knows that I only do what method? I only cross multiply. I don't teach it with reciprocals. I don't teach it with inverses. If you like that method, use it to your heart's content. Okay? But in class, I will only cross multiply. Okay? Because those of you who have weaker math skills, if I multiply with reciprocals and inverses and change the method depending on the topic, it confuses people. So if I stick to one method by the end of the semester, hopefully you'll have it. Okay? Yes, I can do the other way. I just choose not to. So if I multiply and cross multiply, I get 5.64V equals 89.5. Now that I've gotten rid of my fraction, not a soul in this classroom would solve this problem wrong. I need to do what to get B? 5. Not a soul in the room. It's all wrong because I got rid of my fraction, my cross multiplying, which is why I'm a fan of cross multiplying, because everybody does it right at that point. Somebody tell me the answer. Some of y'all. What? 15.9. All right. So to illustrate the difference with units, now look at the word problem. What can you tell me about this unit and this unit? Do they have anything in common? What do you suppose is going to happen to those grams when I divide right here? They're going to cancel out. Exactly. So I'm going to be left with what unit on my volume? Exactly. You see the difference between this problem where nothing is in common and I have to write both units versus this problem where I have some units that were the same and they canceled out. See the difference? Okay. That's the biggest reason I put those two up there. So you can see the difference where the units don't cancel and the units do cancel. Everybody good with that? Okay. All right. We want to do the top one in orange. The blue one I'm not doing at all. I'm only looking at the orange. The orange one is more like something you would see in my class. Write it down and find me the answer. All right. Got an answer for me? What's the identity? Nobody? What? Can't hear you. I need to know the element, the identity of the element. This is looking like a nut. Quite possible. That's an element. It's quite possible it could be. How do you know that? That's exactly what you're supposed to do. Okay? Those blue charts I gave are where you would look. The state test is not going to say at the end of the question, look at your reference table to find the answer. You're supposed to know to do that. Because it says use and identify the element. I have given you essentially 10 pages of reference table. The front page has densities on it at the bottom, correct? Okay. You just calculated the density at the top. What was the density of your element? Everybody yelled out 11.3 number. You yelled out some weird numbers. Okay? Y'all clearly calculated the density. So look at the column that says density, find the element, and what do you have? There you go. Okay? So that would be the identity of the element. So, if I look here, what if I put this on the test? Could you do that? Would you know what I was asking? That's what I want you to do, Mario. Okay, so we go to the top. Okay, so who's going at the bottom then? Let's figure it out real quick. You don't have to actually write it down. Let's just do it. Yeah, she said which one was going at the bottom. Okay, how do you know? All right, that one's 10. This one's what? This one's what? Okay, so who's going to the bottom? Object 4 is going to the bottom. And then, okay, so everybody's good with that concept. Okay. All right, last one. And I would write this one down. Because you're going to see stuff like this on the test. All right, just tell me what you got to do here. Or someone is doing it wrong and you got to go back and fix it. What you got to do? Okay, you got to find the math. What do you think is tricky about the question? Okay, so what do we got to do there? Change what? Right about you got to change it. Which one we change? That's the easiest thing to do. Okay? When you look at this, and I mean no disrespect, but what do students think at the absolute worst of math class? I heard it. Fractions. Okay? Since this is a fraction, I would leave it alone and I wouldn't change it. Okay? I would not mess with the fraction. I would change this one to match the fraction. Okay? Since this one's a fraction, leave it be. I would change this one to match the fraction. So I would change this one to match and change it to milliliters, and that way it would match the fraction. I would do exactly what Andy said to make it match the fraction. Okay? Could you change this one to make it match liters? Certainly, and I'll be glad to show you how to do that if that's what you want to do. Okay? Not a problem. It's just a different step, but I'll be glad to do that. But generally speaking, most students struggle with fractions. So I would leave the fraction alone. So take your 0.054 liters, change liters into milliliters. Who's bigger? 3 spaces. So we're going to end up with what, 54 milliliters. Now everything matches. So you're plugging into density equals mass over volume. So what's the density? 1.65. It says find the mass, so we're looking for M. What's the volume? 54. Now, this is where you have to remember to use the new one that you just converted to, not the old one that they gave you. Now, if you were sitting in math class, you can solve for M again any way you want to. Which way did I tell you I always solve? Cross multiply. So M equals, I multiply those two things. What do I get? 89.1. Check my unit. This is a milliliter. This is a gram per milliliter. Do they have anything in common? The milliliters are going to cancel out. And I'm left with what? And there's my answer. Questions about how I did that? Questions? Does that make sense? Any issues with density? Yes? No? Okay. We're going to talk about accuracy and precision. Finish today. Because I'm gauging today to see where third period winds up. If y'all class is longer, and I won't know till after today if I'm going to need to, where I'm going to wind up with being too far or too short on that. All right. The last thing we're going to talk about today is going to be our discussion. Y'all are going to go nuts with next week. Now, last semester, everybody was like, you didn't tell us this wasn't on the final. Significant digits are not on your final exam. However, you're going to hear me say this, I don't know, 60 guys, 20 down. Y'all are in an honors class, okay? There are things I have to teach in an honors class to make you above and beyond plain old regular college prep. This is one of the topics that I choose to teach to make you above and beyond a plain old regular honors or standard class. So, but look, I know there are people in the building who don't do that. Welcome to honors class. So, before we can do that next week, we're going to talk about two vocabulary words. And those are accuracy and precision. We use these words all the time in the English language. However, they don't mean the same thing as science class. So, what on earth do these words mean? Okay? Accuracy is the closeness of an answer to the accepted value. Okay? The closeness of an answer to the accepted value. Okay? Now, what does that mean in English? Basically, it means getting the correct answer. Being able to get the correct answer is accurate. Now, precision is the ability to reproduce an answer repeatedly. Okay? Now, over there. Let's say a few more times, maybe. Okay. So let's just say with play dog. All right, and I threw my dart. They landed like that. What could you tell me? I'm not accurate. Because where's accurate at? And where? I think that was your voice I heard. The bullseye. I'm not in the bullseye. Okay? So I'm not accurate. All right? Am I precise? Did I reproduce the same thing over and over again? No. All right? not precise either. All right, what if I threw them and they all landed there? Okay, I'm precise because they all landed together, so I reproduced my same answer, but I'm not accurate because I didn't get them where they needed to go. So, in order to be both, where do I need to be? And to hit all of them, need to be here to be accurate and precise. Now, you understand what the words mean? Now, sometimes when I translate that to data, though, people struggle and they think the numbers have to be identical to be accurate. Okay? The numbers don't have to be identical. Let's talk about that for just a second. Okay? Let's say that I'm lab number 1. Okay? Let's say this. Catch up with me. Everybody got what they want? And I'm going to turn the screen so I don't want it to get really tiny. Everybody good? Here he goes out there. Let's say that we're going to do a lab with a density of 1. Okay? And its density is 0.998 grams per milliliter, I believe, unit on that. And let's say that lab 1, 3 of you go in and you do lab, and you come up with data of 0.774, 0.821, and 0.985. And then I have a group that goes in and they do 0.841, 0.838, 0.838. Then I have lab group number 3, has 0.990, 0.899, and 0.99. Okay. All right. Now, what do you think about lab group 1? They're not accurate or precise. They're jacked up mess. They're probably going to fail chemistry. All right. Their numbers are all over the place. My best guess is they don't know how to read scale or the whatever else they're reading. Okay. They're a disaster waiting to happen. All right. What can you tell me about lab group 2? They're what? They're not accurate. What is the correct answer? Correct answer is 0.998, and they got roughly what? They got 0.8. Okay. Now, you see how this one says 0.84? This one says 0.83. They're precise. They don't have to be exact. Okay. If you're only off in that second decimal place, I would be pretty doggone exciting in here. Those are 0.8, 0.8, and 0.8. Okay? Those are precise. They are not accurate, though. Now, the last one. What do you think? All right, so we agree they're accurate. I hear some hemming and hawing on the precise stuff. Okay, so what about the precise? I hear a no, I hear a yes. What do we think? They're around 0.9 in all 3 of them. 0.9, that rounds 0.9, that's 0.9. All right, I would go with precise on all of those. Okay, even though they're not exact, they are pretty doggone close. If you guys came up with data like that, I would be excited. Okay, that's close enough for what we're doing. Okay, those would be the results that I would have given you on that. Questions about what you have right there? Anybody? All right, let's talk homework for just a second. Now, I am not necessarily assigning